Welcome to Solving Linear Rational Equations, Part 1. By a linear rational equation, I mean an equation that's either a linear equation or it's an equation which becomes linear when the fractions are removed. As you can see in our first problem, that's an equation that has fractions in it. And one of the things you have to do when you approach such an equation is decide what you're going to do about the fractions. It's best when it's an equation, when this is an equal sign, to eliminate those fractions, but be aware that those fractions may contain some important information, and we want to take a look at those before we remove them. If you look at the fraction in the denominator in the first fraction and the third fraction, they both contain the factor x. Now if x was 0, that would mean the first fraction was being divided by 0, and so is the third fraction. And you can't divide by 0 in math, so we're going to make a little note over here. We're going to say note x cannot be 0. And let me get a little, I'll go fine point this here. Okay, x cannot be 0. Now once you've determined the values of x which are not legal solutions to the problem, your next job is going to be to get rid of the fractions. To get rid of the fractions, we're going to multiply both sides by the common denominator. Now, you've already gone through a section on common denominators, should know how to find those, but let's kind of go back through it if you've forgotten. To get the common denominator here, since your denominators have both numbers and variables, you're going to have a number part and a variable part. Now as to the number part, that cannot be smaller than the biggest denominator. So we're going to start looking at 9, which is our biggest number. And 3 will divide 9, but 6 won't. So 9 is not the common denominator, so we go to 18. That's 2 times 9. And we see that 3 will divide 18 and 6 will divide 18, but 4 won't. So we go to 3 times 9, 27. And 3 will divide 27, but 6 won't divide 27, so we try 4 times 9. 4 times 9 is 36, and all of these denominators, all of the number parts, divide 36. 6 goes into 36 6 times, 4 goes into 36 9 times, 9 goes into 36 4 times, 3 goes into 36 12 times. So the common denominator number part is 36. Let me try another point here. Nope, don't want that. That's red. There's a good point. Fine chisel. That's what we'll use. The common denominator number part is 36. And for the variable part, there's only one variable, that's x. So the common denominator is 36x. Now once we've determined the common denominator, the next step is to multiply each side by the common denominator, and that should eliminate fractions. Look how I've rewritten the problem here. I've left spaces for multiplying by the common denominator. So I come in here and I say 36x times 36x times, I'm just taking every term and multiplying it by that common denominator, 36x. And after I do that, I can cancel. Here in the first term, the x cancels the x. The 6 cancels one of the 6's, but leaves one of the 6's. And so I end up with 42 as my first term. In my second term, the 4 cancels the 4, but leaves the 9. The x did not get canceled, so I get minus 27x. In my third fraction, the 9 cancels the 9 but leaves the 4, and the x cancels the x, so I've got my denominators gone, and I end up with 4 times 5 minus x. And in my last fraction, the 3 cancels the 3, leaving a 12, so I get minus 12x times 2. Okay? Now, once you've gotten rid of all your fractions, notice I now have an equation which is much easier to work because there's no fractions in it. Once you get rid of your fractions, you now follow the 4 steps that are on the right. It says after fractions are removed, first get x out of the grouping symbol. This is because your answer has to look like this. X equals something over here. We don't know what yet. But notice x isn't in a grouping symbol. That's why you have to get x out of the grouping symbol. So I'll do that step next. It says to get the x out of the grouping symbol by distributing. So I'm going to distribute. I'll distribute the 4 onto the 5, and then I'll distribute the 4 onto the x. So I get 4 times 5, which is 20, minus 4 times x, which is 4x. And then the 12x times 2 is minus 24x. And now we've gotten x out of our grouping symbol. The next step says get the x terms on one side and the non-x terms to the other side. Okay, let's see. I've got 2 x terms on this side, another x term on this side. I'm going to move it to the other side by saying plus 27x and come over here and say plus 27x. My non-x terms, I have 2 of them. I have to move them to the other side, so I'll say minus 20, taking the non-x term off of the right, and minus 20, leaving my non-x term on the left. So on the left I have 42 minus 20, which is 22, plus 0 is equal to 0, and then negative 4x minus 24x is negative 28x. I could have combined those like terms earlier, plus 27x. Step 3 says form a single x term. Right now I've got 2 x terms. It says form a single x term by either combining like terms or you can factor out the x. Here's what it would look like if you factored out the x. Negative 28 plus 27 x, of course that's negative 1, so that's just going to be negative x. Or you can just say negative 28 apples plus 27 apples is negative 1 apple. And you've got negative x equals 22. Now, we're not solving for negative x. We're solving for x. So I'm going to now divide both sides by negative 1. And on the right side, I'll get positive x. And on the left side, I'll get negative 22. But you know, if a is equal to b, then b is also equal to a. So I rewrite it as x equals negative 22. Notice I did not get x equals 0, which was my forbidden value. So this is a good answer, although it's not a bad idea to plug it back to your original equation if you have time to see whether that is a solution. Now we'll tackle a little bit more difficult problem when we do solving linear rational equations part 2. That concludes this podcast.